Hey Jayraj, welcome to Apla Pune, welcome to Ansys. Hi, I am Amit Agarwal from Ansys. Welcome to this podcast on global trends in semiconductor innovation. I have with me Jayraj. Hi Jayraj, welcome to Ansys. Can you share a little bit about your background and role at Ansys?
Dhanyavad, Amit. First of all, very happy new year. Thank you for giving me an opportunity to come here to Pune. I'm super excited about coming back to Pune because it's been a while. I've been in the industry about 35 years. Most of which was in tech, either building a product or getting it implemented at a customer. My role is two-pronged, one of which is that I'm the global CTO for High-Tech, field CTO. So I engage with CXOs and work and build joint solutions together. The second part of the role is very interesting. It is being the APAC CTO. So I get to cover all industries and be an extension of our CTO team back in the US. Super excited to be in India and hoping to make a big difference.
Lovely. Hey Jayraj, can you throw more light on the key trends which have been driving industries like high-tech, mobility, healthcare, industrial energy, and aerospace and defense?
Yeah, sure. I think every industry is going through a major transformation, especially if you look at the high-tech industry. Everything is high-tech these days, right? The application of high-tech in terms of semiconductor or electronic components is pervasive in automotive. Aerospace and defense is growing like crazy. You have mobility, and everybody talks about software-defined vehicles. The time to market of all of these products is getting to be a big challenge. Everybody is innovating. Innovation pace is picking up. So simulation engineering plays a big role in terms of getting these products to market. Let me get specifically into high-tech. I was at VLSI conference in Bangalore earlier last week. For 3 days, I heard about so many architectural changes. So if I parse it into three pieces about technology, processes, and people, let's focus on technology for a minute, that being my strong point. But in terms of technology, the nature of semiconductor is transforming. So you have complex, bespoke silicon being developed for specific purposes. In the silicon, you have the CPU, GPU, NPU, all in a multi-die architecture. You are bringing memory closer to the compute. So you now have a multi-die kind of an architecture. In terms of getting those kinds of silicons out, it takes a long time in the development life cycle. A lot of innovation in the EDA world in terms of optimization, making sure power integrity and signal integrity is good. But because now it's a multi-physics problem, we have to look at thermal integrity, we have to look at mechanical stress and warpage of the silicon. Lots of complexity being added in terms of technology. That's just the design part of it. And now you have the manufacturing and you have all the process nodes going into like sub 5 nanometer range. In addition to the semiconductor technology aspects, people also matter. The skill set to address this new landscape of complex technology needs a good pipeline, good development process. So it's institutionally, the country and organizations need to make sure they can develop the talent along with this transformative technology. So India is making a lot of progress in that space. From a process and workflow standpoint, this multi-physics, multi-domain involves a lot of net new workflows and processes. So that also has to get attention in terms of how those things change to bring new products to market faster. So very exciting time for high-tech. I'm super proud to be in that industry specifically over these many years. And I can see we are at a big inflection. So like Viksit Bharat at 2047 is supposed to generate over $3, $4, $5 trillion of, electronic components, of which semiconductor probably is going to be about 800 billion or more. Now, that is an enormous opportunity for the world and for India in particular. Let's talk about automotive a little bit. I think with the electromobility trends, we are going through a major inflection and transformation. I was super impressed actually with all the EV scooters on the roads and even the new EVs that are being launched in India. The whole electromobility part is taking a net new set of technologies into action, and that requires a lot of focused design engineering work. In addition to electromobility, you can look at ADAS systems and autonomy. Active driver assist systems are very complex. They give a lot of data into the system that needs to be computed and processed. The various levels, and I don't know whether you've sat through one of these autonomous cars in the US, super impressive, but it takes a lot of underlying high-tech technology to make that happen. Even the design life cycle, model-based simulation engineering, all of that is very, very much essential to making the time to market smaller. Because a lot of new models, a lot of excitement in the market, continuous iterative innovation, cost reduction, all of that requires the automotive industry to be on its feet. You've seen a lot of changes in the leader pack of all the various automotive OEMs that are coming to market. I think as India is progressing towards Viksit Bharat, I think the automotive sector needs a big focus. Let's talk about healthcare as well. We have an aging population around the world. Especially I'm moving to Tokyo, and Japan has a big aging population. The ability to deliver personalized care is very well connected with the models of human subsystems that we can build. And there's a big push of shifting from the traditional clinical trial models to going into in silico trials. And a lot of innovation has come from Ansys in that space. I think adoption of these technologies and ability to deliver very personalized care using healthcare solutions is super important. I'm actually so amazed when I look at us understanding our heart as a mechanical pump, right? And you can actually see the amount of stresses and the finite and the geometries of the heart and how finite element analysis methods actually help you understand the implications of what you could do surgically in one part of it versus the other part. So understanding and having a good digital model of our physical body parts as a complete holistic system really can make a big impact. And I think we have made a lot of progress in this area. Let's talk about industrial sector. Every asset these days is smart and connected, right? So you get a ton of telemetry about it. How do you leverage all of that? If you have a holistic systems of systems model of a factory floor and all the piece of information that is coming in can be understood, you can do magical things with operational efficiencies. You can actually predict failures. You can do corrective actions and avoid, unplanned downtime. So what that does is the return on investment of a factory and of a specific asset gets better. So industrial assets that are, it's all about asset performance management. You can transform the way a factory is operating by having a digital twin of the factory that you can look at and understand. Let me talk about energy, right? Every one of these industries we talked about so far consume a lot of power, a lot of energy. How do you make sure that you have some good levels of energy efficiency in the system? I think it's all about monitoring, measuring, managing. What you measure is what you can manage. So the smart connected systems actually help in this way. But they're a net new source of energy too. You have plenty of windmills in play here in India and everywhere. You have a solar option. You also have hydrogen source of energy. So it's not just about the production of energy per se. It's also about how it gets distributed and how it gets consumed. So utilities, modeling this entire system of systems from the production all the way to consumption of energy is super important. There's a lot of transformation happening in the energy industry, and every one of us can actually, from a consumer standpoint, contribute to minimizing the impact of climate change. I'll be remiss if I don't talk about aerospace and defense, which is a big changing industry as well. Just like semiconductor and electronics, you have a lot of push from different governmental agencies in terms of investing in aerospace and defense. Aerospace in particular is my favorite because as a kid, I used to follow ISRO very closely and in fact have a few relatives who worked there during their time. I think the whole notion about space and exploring the unknown. And you look at the number of startups now within space in India. It's amazing what we are doing, what Japan is doing, what the rest of the world is doing in this space. So aerospace as a sector is primed for technologies related to design, development of vehicles, of payload, the whole mission engineering concept. And it's all tied to systems engineering. Good systems engineering is a prerequisite to a successful space mission. And there are so many examples right here in India that we have seen.
Jayraj, thanks for sharing your perspective on the global industry trends. Now, shifting gears to regional perspective, can you share your thoughts on what role APAC has been playing in the growth of semiconductor industry across, and also where does APAC fit into the global semiconductor ecosystem?
Great question. It's going through a lot of dynamic changes, especially after COVID. You saw a lot of shortage of semiconductor in different parts of the world. Every industry got impacted because of that. So there's been a lot of transformation happening. I think the governments took a big initiative, and most governments. You have the CHIPS Act in the US, you have the European spending a lot of money in investments. In APAC, India, Japan, Korea, Taiwan, all the governments have various levels of incentives. And I was super impressed with what's happening in India. I was at the VLSID conference last week, so I heard a lot about the initiatives in terms of manufacturing of semiconductor. The supply chain is very complex. If you look at the design life cycle of a semiconductor silicon, Indian companies have been playing an oversized role in it. I mean, majority of the talent for semiconductor design with EDA tools is predominantly in India, right? So it's super exciting to see that. So we have the talent and the skills in India. In terms of manufacturing of silicon and semiconductor, there are a handful of foundries, and in fact, TSMC produces a significant chunk of semiconductor. You have Intel Foundry, AMD, Global Foundries, basically, and then you have SMIC in China. So literally across the semiconductor manufacturing, India's footprint in that space is less, but there's a lot of incentives that the government has provided, and I know a lot of fabs are getting built in India, especially in various process nodes. I think advanced process nodes are a big challenge at this point in time, but the country is pushing forward with getting the manufacturing hubs started. The supply chain is really complex, but everybody has a role to play in the supply chain. And India in particular has a significant opportunity in front of it.
So Jayraj, you spoke about challenges, you spoke about ecosystem. Can you share more light on where does simulation fit in? What role simulation has got in all of this?
It's ubiquitous. It's pervasive. It's everywhere, right? So the pace of product innovation is very different now. It's much, much, much faster, right? So if you have the complexity of the subsystems has gone up, so you have to simulate many of the digital variants of the product vis-a-vis a physical variant. The time to market has shrunk. You have to come up with innovative either derivatives or new innovations constantly, right? So to do that, you need to simulate. The return on investment and the cost associated with physical versus digital is substantially different. It's an order of magnitude. So you have to focus on simulation engineering. I think the whole model-based simulation engineering, the digital engineering processes, the way these systems come together, the architecture, the dynamics of these systems is very different now and will get more and more complex and advanced in the future. So we should focus on good engineering practices that put simulation engineering at its core.
Lovely. Jayraj, thank you. Thanks a lot for joining this podcast on semiconductor innovation and sharing your views. We look forward to having more collaboration with you. Dhanyawad.
Dhanyawad. It's been a pleasure.